Hello everyone. Today we will talk about new topic. This topic is very important for the SAT2 exam or for the SAT subject exam. In this class we will talk about sequences and series. Okay, so let's take a look at the definition of a sequence. A sequence by definition is a function f, whose domain is a set of a natural number, and these values f1, f2 and f3 and so on, we call them the terms of the sequence. So basically a sequence is a set of numbers. These numbers are written in a specific order. So in this case we have the first number a1, the second a2, a3, a4 and an. So each one of these numbers, we call this a term of this sequence. So this is a sequence, these numbers are sequence, each one of these numbers, we call this term of the sequence. Let's take an example. In this example we have this sequence 2, 4, 6, 8 and 10 and so on. So this 2 represents the first number or the first term of this sequence. This 4 is the second term. The 6 is the third term and so on. Let's notice the relation between these numbers. For example, in this case, this 4 is 2 multiplied by the index of this number. So it's basically 2 multiplied by 2, while this 6 is 3 multiplied or 2 multiplied by the index of this number, which is in this case 3. This 8 is 2 multiplied by 4, which is the index of this term. Let's say we have the 2n term. The index of this term or the index of this number is n. So how did we get this term? By multiplying 2 by n, we got 2n. So guys, there is a difference between the index of this term or the term itself. So this is the index, which is n in this case, while 2n is the number or the term of this sequence. So we can use the notation which is an, which is the term of index n equals 2n. Why? Because each one of these numbers, we can find it by just take 2, multiply this 2 by the index of this term. So in this case, this 8 is 2 multiplied by 4, so we get 8, and so on. So we can use the notation, the function notation, and we would say a of n equals to n, or the index notation, so a with index n equals 2n. So this 2, which is a1, the first term of this sequence, a of 1 equals 2, a of 2 equals 4, a of 3 equals 6, and so on. So again, this is the most important term of this sequence. In general, we can say an equals, in this case, 2n. So for this sequence, the formula which defines the an term equals to 2n, which is very simple. Just take the index multiplied by 2, you will get the term. So we call this the formula which defines the sequence. In this case, an equals 2n. Let's take another examples. So in this question he is saying find the first 5 terms and the 100th term of the sequence defined by each one of these formula. Let's take A as an example. So in this case, an equals to 2n minus 1. So instead of defining the sequence by 2n, as we did in the previous slide, it's 2n minus 1. This one here, Rn equals negative 1 to the power n over 2 to the n, and so on. So for each one of these sequences, we can define its own formula for the nth term. So how to find these first 5 terms? Let's start by the first one. So we start by substituting n equals 1, starting from 1, 2, 3, 4, and 5, because we need only 5 terms. And we need the 100th, so we can replace n by n equals 100. So for the first one, which is an equals 2n minus 1, let's say a 2n minus 1. So if n is 1, 2 multiplied by 1 minus 1, which is 1. If n equals 2, 2 multiplied by 2, which is 4 minus 1 equals 3. This is the second term. N equals 3, so 2 multiplied by 3, 6 minus 1, which is 5, and so on. While n equals 100, 2 multiplied by 100, which is 200 minus 1, this would give us 199. So basically, you take the formula, you take n, you substitute, you plug n in this formula, and you will get the appropriate or the corresponding term of this sequence. Look at this sequence in this case. Negative 1 to power n over 2 to the power n. If n equals 1, so this would lead to negative 1 to power 1, negative 1 over 2, which is negative half. While the second one would be positive because n is 2, and so on. So basically for each one of these formula we can get a different term, and we call this term Cn, or the nth term, or the formula of this sequence. So the formula of this sequence is the nth term of this sequence. Guys, we have to notice that in each one of these formula we can define the nth term by only n, without any previous terms. So this an depends only on n, not the previous one, which is an negative 1. Even in this case we have the same thing. We have Cn depends only on n, and so on. But we have a different type of sequences. So each one of these terms, nth terms, depends on the previous ones. So we call this sequences, or this type of sequences, recursively defined sequences. Let's take a look at these types of sequences. So by definition, recursively defined sequence is a sequence which depends on some or all of the terms preceding it. So it depends on the an negative 1 or an negative 2, and so on. Any sequence defined in this way, we call this recursive sequence. Let's have a look. Look at this example, guys. And this example is asking me to find the terms of recursively defined sequence. So find the first 5 terms in this sequence defined by an equals 3an negative 1 plus 2. And he's telling me a1, the first term, is 1. So instead of having an depends only on n, in this case an depends on the preceding terms, in this case only a negative 1. So how to find the first 5 terms in this sequence? So basically we have to start one by one. In this case, the first one, which is given, a1 equals 1, so I have to find n2, which is the second term. a2 in this case, a2, so now n equals 2 equals 3, which is 3, multiplied by the previous term, which is in this case a1, because we are calculating a2, plus 2. We find the answer, which is 9. So now to find a3, we take the previous one, 3 multiplied by a2, plus 2, and we find it, which is 33. a4 at the same way, 3 multiplied by the previous one, we get a4 and a5, and so on. So we call this recursive sequence or recursively defined sequence. an depends on the previous terms instead of depending only on n. So to find the n or an, basically we have to find the previous terms to be able just to find an. That's why in this case a1, which is the first term, it's given in this case. Thank you guys, hope you enjoyed the class. See you.